Ordinary linear probing can push unlucky keys farther and farther away, making lookup time unpredictable. Robin Hood hashing has an unusual rule. A key farther from home may take the slot of a key that is closer to home. This is an open-addressed hash table. Every key has an ideal position from its hash function, called its home slot. DIB counts how many steps a key has probed to the right from home. Robin Hood hashing uses it to decide who is poorer. If probing passes the end, it wraps to the beginning. The mod keeps the distance non-negative. A hashes to slot 2, it is empty, so A lands there with probe distance 0. B also hashes to slot 2, but A is already there. B moves right to slot 3, and its dib becomes 1. C hashes directly to empty slot 4. Even at the end of the cluster, its DIB is still 0. Now insert D, whose home is also slot 2. At slot 2, A and D both have dib 0, so no swap. D moves to slot 3, reaching dib 1. B also has dib 1, so still no swap. At slot 4, D is 2 steps from home, while C sits at home with distance 0. D is poorer, so it takes C's slot. The displaced C continues right and settles in slot 5 with DIB 1. One swap has evened out the probe distances. To find D, start at its home slot 2, inspect A and B, then continue right. D is found in slot 4. Lookup is still ordinary linear probing, but probe distances in the table are more even. Search for missing X from its home slot 3. Slot 3 holds B, slot 4 holds D, neither is X. At slot 5, the search distance is 2, but C's dib is only 1. If X existed, its dib would be at least 2, and it would have displaced C during insertion, so X is not in the table. Robin Hood hashing does not eliminate collisions. It controls the variance of probe distances through swaps. It gives up a few lucky zero-distance placements in exchange for steadier lookups and reliable early termination on misses.